Halo, Assalamualaikum dan selamat sejahtera. Apa khabar semua? How's everything? Wish all of you are well despite this MCO thingy going on. So we're going to continue. Welcome back to Instrumentation and Measurement. Today we are going to continue on Chapter 7, which is on Sensors and Transducers. Okay. So these are the objectives of the topic. We're going to go through one by one. Okay. So let's move on. So we're going to introduce to you to sensors and transducers. First of all, we're going to start with sensors. Okay. So basically, sensors are devices which detect events or any physical changes for physical stimulus and turns it into a signal which can be measured and recorded. Okay. So it sends something and it turns into something that we can measure. So in other words, it's a sensor. You can also define a sensor this way. It's a device that reads from the environment as input and present the data that we can read and understand or share and record it as output. Okay. So basically the input can be, for example, any physical motion or movement, heat, light, chemical reactions, and so on and so forth. Okay, and the output of a sensor can be a number or the data or any physical thing that we can see. For example, resistance or physical level. Okay, so no alteration happen. Basically, a sensor is a raw device that get an input and turns into an output. So you have any physical. This is just to show you the chart. Okay, it has an input into the sensing element. Okay. And then the sensing element will then sense and respond the input and change it into a response and output. These are some of the example of sensors. We have a lot of type of sensors out there. Temperature sensors, alcohol sensors, smoke sensor, light sensor, and so on and so forth. And this is not all. Actually, there are hundreds more type of sensors out there. You can search around if you want to. Okay, let's talk about transducers. Sensors are basically interchangeably introduced as transducers. Okay, so in most general term, a transducer is any device which converts one form of energy into another. Okay, that is the most general term. So you're gonna see that there are a lot of equipment out there that can change one energy to another. For example, a solar cell, which converts light into electricity. A light bulb converts electrical energy into optical energy. Okay. Electric motor is a transducer which converts from electricity to mechanical energy. Okay. Pressure transducer. Okay. So basically, this is the type of a normal item that you see every day. Okay. In terms of measurement, so in the topic of instrumentation and measurement, a transducer can also use a device can use to transform other. From one energy to another. For example, if you have a pressure transducer, it means that it's a pressure indicator. It is also called a manometer or pressure sensor. So the input is the pressure and the output is an electrical signal. So it's also changing one energy to another. Okay. So this picture on the right here is just an example of a solar cell, a light bulb that we see every day, electric motor, and pressure transducer. Okay. So another also example of transducer, we are going to talk about some of these measurement transducer later on in our subject. So there are also piezoelectric transducer, which convert mechanical energy to electrical signal. For example, if you have an electronic drum, right, a drum, or maybe a piano that sends a pressure of your drum or something, then it will detect that and change it into electrical signal. Okay, ultrasonic transducer, the ultrasonic thing that's that used to sense ultrasound wave, okay, in order to measure distances. Temperature transducer to convert temperature to electrical signal. Microphone and speaker, okay, so we have let's say a microphone here. It will change from a sound wave into electrical wave, and then back into the sound wave. We have a loudspeaker, okay. So and so on and so forth. There are thousands and hundreds type of transducer out there. Okay. So in this class, we only focus on electrical transducers for measurement purposes. There are also mechanical transducers and transducer which is not used for measurement, but in this class we only focus on electrical transducers which is used for measurement purposes. Okay, what are those things? So electrical transducer are devices which performs the following. Okay, there are two basically criteria, or what you call characteristic of an electrical transducer. First, it sends any non-electrical quantity. For example, temperature, sound, light as input. Basically, that's the thing that you want to measure. Okay, and secondly, it will transform the input signal into equivalent electrical signal, which is voltage and current anyway, proportional. This keyword is here, proportional to the input measurement parameters, sense or quantity as output. Okay, so the greater the input, probably the greater the output. Okay, so the input is basically for a transducer are all type of physical stimulus or physical changes. Stimulus is something that stimulates something. Okay, and the output is basically is a processed electrical signal, or you can say it's conditioned. Condition means it has done some manipulation on the data. Okay, so it may be either analog or digital. Okay, so when I say normalized or conditioned, it's basically like this. The output electrical signal is normalized, means that it is put into a scale proportional. For example, if you have a very low value, it is set to 4 milliamp, and for the high value, the output will go up to 20 milliamp perhaps. It can go to maybe more or less, depends on the manufacturer of the transducer. But typically, it's between 4 to 20. I would say it's an international standard that uses 4 to 20 milliamp as a normalized scale for transducer. Okay, this is very important, how to differentiate between transducers and sensors. A transducer device must include sensor. Okay, so sensor is part of transducer. Okay, so basically you can say that transducer is a sensing element plus a transduction element, or a transducer. Okay, so a block diagram is like this. So you have a physical or non-electrical quantity. It is sensed by the sensing element. It can be anything like a thermistor or anything like that. Okay, so it is sensed and responded by the sensor. Or response means it will produce an output, some non-electrical sensor, something like that. And then this output will be sent to transduction element. That's where the word transducer comes from. Basically, it's transduced, it's convert this electrical, non-electrical signal into electrical signal proportional to the input quantity. Because with some data manipulation is done in that element. Okay. For example, when you say normalize here, for example, let's say I take a temperature transducer which measures 0 to 100 degrees Celsius. Okay. So this transducer will produce an output in such a way that if the temperature is 0 degrees, and the output will be, let's say, 4 milliamp. And if the temperature is 100 degrees, then the transduction element will produce 20 milliamp. So in any in between, it will produce any in between 4 to 20. You understand? Okay, it's not very difficult. I think I've used this before during my time I spent in a power station as a control instrumentation engineer, and we used to, when we do calibration, we calibrate the transducer according to this value. Okay, so this normalized electrical signal. And then this normalized electrical signal is sent to a database system or computer PLC for example, you want to do some analysis, you want to do some control, and so on and so forth. So if we look at this block diagram, then a transducer is basically this block here. Okay, so this whole block here is a transducer. Okay, so it contains the sensor plus the transduction element. That's the input, and that's the output for this is the input for the transducer, and that's the output for the transducer. The whole red block things is called a transducer. So maybe I'm confused again, how to tell the difference between sensors and transducers. Okay, let's take a simple example, a thermistor perhaps. Okay, if you look in Google, if you search around, a thermistor basically is the type of resistor whose resistance changes at different temperature. Okay, this called thermistor. Okay, if you put a different temperature across the terminal of the thermistor, it will rise. If the temperature rises, the resistance, if you put a measurement multimeter, the resistance will increase, and vice versa. Temperature drop, resistance also will drop. Okay, so let's take a look how different is with a sensor? A sensor, so the thermistor itself is a sensor. This is how it looks like. Okay, so you have a temperature as the input, and the sensor itself is this is the thermistor, and it will react in a way that it will change the resistance. Okay, that's the measurement. So thermistor, it senses the difference in temperature and convert it into a change of resistance. So a transducer, basically, you have the same thermistor, okay, the same type of input, and then the same type of output from the thermistor, but there's an additional task is going on here. This change of resistance is sent into what they call a bridge circuit, and I think you have learned that before. And then this bridge circuit, you know, they have a AC signal and the voltage signal here, and then it will change into an electrical signal output. Okay, so a thermistor is, when a thermistor is connected to a bridge circuit and produce electrical signal, then the entire device is called temperature transducer. So sometimes in some textbook or sometimes in industry, it's also called, simply called transducer, because maybe transducer word is too long to pronounce. It's called, okay, it's a temperature, it's a thermistor. Okay, all right. So so electrical transducer is a device that converts a physical or mechanical or optical quantity into proportional voltage or current quantity. Okay, so we're going to talk a little bit about parameters of electrical transducer. Okay, the parameter, it has to be, for example, it has to have some linearity. So when the input changes, the output will also changes linearly. Okay, sensitivity, it has to have a certain sensitivity. Okay, the higher sensitivity is much more desired than the lower sensitivity. All right, for example, you want to change of voltage, how much voltage in terms of temperature, and the dynamic range. The transducer must have a suitable operating range. The wider the range is better. And repeatability means that the input-output for the transducer should be predictable and consistent. It can use the transducer again and again. If we measure the same amount, it will have the same result. Okay. And physical size. The physical size should have a minimal weight and volume, because sometimes you're going to bring that transducer up to the field, have to maybe exposed to rain, different temperature, and has to be also portable to be used. So these are some of the practical parameters of electrical transducers. Okay, this is basically some of the differences. I put in a table like this. I think you can go ahead and read the difference between both two. Okay, we are going to continue on my next video on part 2, which is on classification of electrical transducers, and we are going to talk about other part of the transducers as well. So I'll see you again in our next video. Thank you very much. Have a nice day.